Hey guys, welcome to part 3 of the Lightbulb application. What I want to do today is enhance the user experience by improving our in-app routing. So the first thing that I want to do is I want to make it so that the user doesn't have to know this full URL in order to get our Lightbulb. So if they were to go to localhost 4200, they would just get an empty screen. And that's because we didn't specify a path that loads one of those named outlets. But that's something we can fix really easily. We want to bounce them from localhost 4200 to this path. So all I need to do here is add another path. I'm going to say path is just an empty path. I'm going to say path match full, so it only matches the empty path and not any children of the base path. And I can just say redirect to / bulb off. So now when we hit the base path, we should just get bounced to the light bulb. So let's try it out. So if I go localhost 4200, I get bounced to bulb off. So that's a good start. So the next problem is that we can load the application in an invalid state with a state that's not on or off. So if I could change this to on and off, which we aren't handling in our application, but it still renders. And when I open the switch, it's opening the switch with that on and off because we're just loading the switch with whatever the current state of the bulb is. I mean, it starts working, but it's still kind of misleading. Before we load our route, we need to actually check that state parameter. So I'm going to do this using route guards. Route guards are an Angular tool that you can use to do some checks before deciding whether or not to grant a user access to a path. So the most common use case that I see for route guards is controlling what different kinds of users might see in your application. So if you have some kind of authentication service so your user can log in and have an active session, you might want to show some extra things to people who have administrator privileges. Now, something important to note is that you don't want to use guards as a means of securing your application. A clever user would be able to get into your code, change a few things, and bypass those guards. So anything in terms of security should be done server side. But I'm going to use guards to do a couple of things. I'm going to make sure that the state is either on or off. And I'm also going to make sure that this light switch can only be opened in a pop-up window. So the first thing we need to do is create our guards. So I'm going to navigate in. I'm going to make a new directory, guards, just to put my guards in one place. And now I need to generate my guard. So I can use ngg guard. And the first one I'm going to do is light bulb. So I'm going to have a specific guard for my light bulb. So there's a few different kinds of guards that you can implement. I'm not going to go through these. If you want to know what each of these mean, you can go to the Angular documentation. It explains it really well. But I'm going to use can load. And that's because I'm using load children. So this is the guard interface that we need to use for lazy loaded modules. And then I'm going to do the same thing again for light switch. So I'll have a light switch guard. I'll select can load again. And now we're ready to implement these. By default, it's just going to return true. So the default implementation is just to grant access. Now I'm going to wire these up right now. So this shouldn't change anything, but at least my guards are going to be working. So I can add something to each of my paths. I'm going to say can load, takes an array of guards that it will execute in order. And for the light bulb, I'm going to say, I'm going to use the light bulb guard. And for light switch, say can load, light switch guard. So this shouldn't have changed anything because we're just returning true. So it's always going to allow us to render the bulb no matter what. So I can say off with a whole bunch of Fs, and it's not going to change anything. Let's fix that one first. So the can load function gives you two things. It gives you route, which is a definition of the route that you're trying to navigate to. And it gives you these URL segments. So it's giving you the exact URL that the user is trying to get to. So the first thing that I need to do is actually get access to what the state is that the user is trying to load. So I'm going to say const state equals, and I can dig this out of my segments. So I can say segments 0 dot path. So the first segment's path. So now we've got that state that should be on or off. And I can do the same check that we're doing in here when we get a new message. So I can just take that same check and I'll say if, and instead of event.data, I'll say state. So that state should be on or off, or it might be something else. If we do have on or off, I'll just return true. So we're good. Otherwise, I'll return false. And I know this is kind of a weird way of writing it. I could have just returned this condition, but it'll make sense in a second why I did it this way. So now, if I go to bulb off and then make it not off, I'm not granted access. But that's still not quite where we want to be because now the user's back to that empty page that we didn't want them to see. So what we want to do is instead of just returning false, we want to actually bounce them to a valid page. So we can do that with the router. So I'm going to get access to the router through dependency injection. So I'll say private router is a router. And before I return false, I'm going to do another one of those navigations that we did in the previous videos. So I can say this .router.navigate outlets, and I'll say bulb off. So if we navigate to an invalid state, we should get bounced back to bulb off to the default state. So let's try that out. So I'm going to just type in some gibberish, and it bounces me back to bulb off. So we're good. Now we're always only going to have bulb on or bulb off. We'll test on just to be sure, and we're good. And we can navigate back and forth with the switch. Now the other problem that we have is that we can still load the switch in this main page, but because we changed the functionality so it's trying to post to a different window, this doesn't work anymore. We're changing the switch to on and off, but it's not connected to the bulb in the same way. So we want to make sure that this switch can only ever be opened in a pop-up window. So I'm going to open the switch guard. And if you remember in one of the previous videos, we can check to see if the current window was opened from another window. So we can do that check here. So I can say if window.opener return true. And so now if the window does not have an opener, then we're not in a pop-up window. So we can do the same thing again. We can route the user to a page that we want them to see if they give us an invalid page. So I'm going to get access to the router again. If we're not in a pop-up window, I'm just going to say navigate by a URL. I'm going to navigate back to the base path and return false. So now we should get bounced back to that base path. And since we have a redirect on our base path, it should take us to the light bulb with the state being off. So now if I say switch is on, so I'm even going to give it a valid state, I get bounced back to bulb off. So now it's impossible for the user to get into an invalid state or to load the light switch in the wrong window. It can only be opened in a pop-up window like this, and everything still works. So that's where we're going to end this one. In the next video, we're going to do a little bit of refactoring, and I'll introduce the concept of UI or presentation components versus routed components. And that's going to make it so that our application scales a bit better, and so it's easier for us to test the application. So I'll see you then.